Last year, our QA/Q started telling us something was wrong, not because QA was weaker, because AI coding had changed the speed of development without changing the speed of human judgment. That is when I started thinking, a lot of software work is becoming a one-person project again. The old software process was straightforward. First, a business analyst clarifies the requirement. Next, a designer shapes the solution. Then, a developer implements it. QA tests the code. UAT validates it. Finally, the team deploys. That process wasn't flawed. It addressed the challenges of its time. Execution came with a high cost. Writing code took time. Modifying code took time. Grasping a large system took time. To manage this, we divided the work among different roles and used handoffs to spread the risk. AI changed the cost structure. Now, one developer, with the help of AI, can handle multiple steps in a single working session. They can clarify requirements, compare solution options, generate the implementation, write tests, draft documentation, explain the differences, and prepare a review summary. The process hasn't gone away. It's just condensed into a more focused unit of responsibility. As that shift occurs, every old handoff begins to feel more burdensome. AI does make coding faster, that's a fact, but there's something more crucial to consider. AI shifts the bottleneck. The slow part isn't typing out code anymore, it's grasping the changes that come along with it. AI can generate hundreds of lines of code, create tests, draft a migration note, and assemble a pull request description in a matter of minutes. A human, however, cannot effectively review all that in the same time frame. Reviewing goes beyond just skimming text. It requires reconstructing context, assessing intent, identifying risks, and determining if the change fits within the overall system. If every engineer on a project leverages AI to produce more work, the team might not actually get faster. What often happens is that the workload shifts from development to review. This creates a growing knowledge gap. The engineer utilizing AI has all the local context, while the reviewer is left looking at a diff. Dora's research aligns with this trend. AI certainly boosts individual productivity, flow, and satisfaction. However, without strong tests, small batches, clear ownership, and quick feedback, teams might find AI revealing more issues related to throughput and stability. The takeaway isn't that AI hinders delivery, instead, it's that AI amplifies whatever system it's integrated into. I use the term one-person project because it can be misinterpreted. It doesn't mean that one person works alone. Quality assurance still matters. Teams aren't obsolete in this context. A one-person project means there's a single accountable owner managing the entire context. This includes understanding user intent, navigating code-based constraints, maintaining the quality bar, and assessing release risk. It also involves recognizing the trade-offs that aren't easily captured in a ticket. AI increases the execution range for that owner. One agent manages design comparisons. One handles drafting tests. One examines the code directly. One creates documentation. One reviews the differences before a human steps in. The owner maintains the responsibility for judgment. The agents tackle specific tasks. They don't bear the full responsibility. This distinction is important because generation doesn't equate to accountability. AI can create a pull request. A human takes on the associated risk. AI can generate tests. A human determines if those tests serve as valid evidence. AI can clarify a diff. A human assesses whether that explanation holds true. A model outlines collaboration in 4 parts. The owner is responsible for the project. Agents assist the owner by managing specific tasks. Boundary sets the limits of authority and responsibility for both the owner and agents. Evidence records decisions and actions during the process. These elements clarify roles and improve workflows in an AI-driven setting. The owner maintains context and accountability throughout the process. Agents support execution. Boundary refers to what the team establishes together. This includes architecture rules, API contracts, repository instructions, security limits, and release policies. Defining these boundaries enables one person to work efficiently while keeping risks to the system low. Evidence shows that speed can be trusted. Tests, logs, screenshots, risk notes, rollback plans, and production signals are crucial. With the rise of AI output, the demand for evidence grows. Manually connecting every detail is no longer practical. This also impacts our review process. The level of risk varies with changes. For a small, low-risk change backed by solid evidence, we can do a quick review. On the other hand, a cross-boundary change, like a migration, permission adjustment, or architecture shift, requires careful consideration. The whole team must be involved. This isn't about adding layers, it's about finding the right balance between safety and speed. There's a flawed interpretation of the one-person project. This view implies that AI's capabilities mean a single skilled individual can work quickly. It encourages cutting back on QA, minimizing review steps, and seeing the process as a barrier. The focus becomes maximizing visible speed. This creates quick fixes, but it leads to a larger problem. You end up with duplicated code. Interfaces start to diverge. Tests often only cover ideal scenarios. Security and permission boundaries can be overlooked. Business rules frequently get buried in prompts, temporary decisions, and unreviewed code. QA remains critical, but its role is evolving. Now it emphasizes risk and evidence design. We set acceptance criteria before coding starts. High-risk paths are assessed before the pull request. Tests are based on requirements and prior bugs. Exploratory testing is essential, especially where human judgment is involved. Production monitoring begins after release. The focus shifts from, did QA check this at the end, to, what evidence can confirm we're ready to ship? The real shift isn't about headcount, it's about how we structure accountability. In the old model, we divided responsibilities across different roles and relied on processes to connect everything. With AI, that connection becomes more costly. Execution isn't the limiting factor anymore. Now, context and judgment are what matter most. One clear answer: designate one owner and a shared boundary. Assign one person to manage the entire loop. Then, set the boundary for the team. Ensure every major decision is based on solid evidence. AI output lacks an owner. When there are no boundaries, the owner's speed increases system risk. Without evidence, trust erodes and turns into mere opinion. That isn't a reduction in teamwork. It's teamwork evolving to a more complex level. The most effective AI-era software teams will shift their focus. They won't just ask what each role does, they will pose more precise questions. Who owns this from start to finish? Which agents can be utilized effectively? Where do the team boundaries lie? What evidence gives us the confidence to ship this? Teams that can address these questions will keep individual speed while maintaining overall quality.